So I think we're back to talking a little bit about wind turbines. I know we talked about them on some prior podcasts, but Shep has been bringing some pretty good articles to the table here. Obviously, we're talking about broad scale, long term transition in energy from fossil fuels and how we're making that leap over to wind power, solar power, in a larger sense, in a larger energy infrastructure sense. So this first story he brought to us tonight, it's pretty interesting. There's a professor out of Stanford University, John DeBerry, who's been working with a different profile for wind turbines. It's actually a vertical configuration. We get a little bit of video here on it. I can play in the background and then bounce out to Shep here to give us a little bit more detail on what we're looking at.
Well, these little vertical wind turbines are basically so neat, and they take up such little space, and it really doesn't take much wind power whatsoever to generate the power potential of what these little turbines are capable of doing.
So I was reading a little bit about the article, and there's some interesting points here we can see in the video. And I know this is a demo setup that they've got going, as the university tests out different things. But one thing they did point out was that these vertical turbines are portable. So they're able to be reconfigured depending upon, what kind of efficiencies they're getting out of them. And they also indicated that, unlike traditional turbines where you really have to space them out in order to avoid the wash from one turbine impacting another one, these vertical configurations actually become more efficient when they're closer together. They actually benefit off of each other.
Yeah, it's
which was really
close proximity to perpetuate the wind, and are supposed to be safer for birds. Bats produce less noise pollution, and could be used in efficiency in urban areas because of their small size.
Very cool.
And
very cool.
Today's wind turbines are the large spread out horizontal wind turbines, and they have to be circumferentially spread apart in such a displacency, unlike these little miniature wind turbines where they actually work more efficiently closer together.
And the other point was that because they're vertical, they're independent of the wind direction. In other words, it doesn't matter. You don't have to orient them to always be facing the wind.
Exactly.
Just because of the configuration. That's pretty ingenious.
I've seen them in Holland before in quite a few places, but it's, how big are the farms that have created these things so far?
Don't know. This one, as I said, this is a test out of the University of Stanford University. There is another article that Shep did bring, though, of a larger implementation that's going on out of Germany. And just bringing this up here, if you want to share that up, this is I think it's one of the largest vertical turbines that are out there.
Exactly. This wind turbine is what they call the Vertical Sky A32. It has a diameter of 32 meters. It's 105 meters high. It's expected to produce 750 kilowatts. The A32 wind turbine will be the smallest product in a series of wind turbines, ranging from a 750 kilowatt to 1.5 megawatts. The real-time rotor blade pitch control means an active continuous blade adjustments, which allows for high efficiency and low rotation speed. Therefore, the rotor blades are always at optimum angle of attack of the incoming airflow. The video shows that the test run in a fixed pitch mode, updated 24th of November, talks about the slower impeller speed, and it doesn't really matter unilaterally which way the wind is blowing. They still generate power any which way they turn, which is so amazing.
So that it gets that benefit from being vertical. But as you mentioned, because it is a much more elaborate, setup here, it's much larger and it's more intricate. They do have the articulating blades, which makes it a little bit different from the earlier project we were looking at, and which, as you said, in addition to the fact that it's vertical and is independent wind direction, you can fine tune the efficiency by articulating those vertical blades to give you the angle of attack that you need to again get optimal power out of it.
Exactly, and it doesn't matter exactly which way the wind is blowing; they will generate power.
Beautiful.